Hi, very good day, everyone. I'm Uday Kumar Sathisilan from Group 2 to here to present the question 2 for tutorial 4. So, the first question for the question 2, the operation of squirrel cage induction motor will change when the voltage supply frequency is decreased. Predict 5 changes and briefly justify each of the changes. So, this is the schematic for the squirrel cage induction motor. And so, what are the 5 changes? First, the speed change. The speed will decrease. So we all know the formula, speed formula, and R equal to 120 FOP. So when the frequencies changes, especially when the frequency drops, speed drops as well. Second, the flux or increases. Flux increases possibly due to saturation core. Third, higher magnetization current, cause of reducing power factor and no load current. Fourth, overheating. The slip increase, torque will decrease, causing rotor heating. Fifth, increased core losses. Higher flux causes saturation, leading to increased core losses. So these are the 5 changes. So for the second question, a three-phase Y-connected 35 horsepower, 400 watts, 50 hertz, four-pole wound induction motor has a stator resistance and a stator refer, referred rotor resistance of zero point 0.2 ohms and 0.26 ohms and 0.24 ohms respectively. The rotational losses are 450 watts, while the core losses are 550 watts. Assume that a constant full torque load torque is connected to the motor shaft and the change in the rotational loss is due to the change in the speed is negligible. So first we have to calculate the motor current and the speed of the motor. So first of all we calculate the speed, uh, the total of 1500 rpm. Then we calculate the P out, we convert the 35 horsepower into watts. So we get to 26,110 watts. So we calculate the power developed, which is 26,560. And also by using the formula, we can obtain the speed of the motor. Next, from there, the X equivalent is given. So from using that equation, we can obtain the current. So now for the second part, a resistance is added to the rotor circuit to reduce the motor speed by 8%. Determine the value of the added resistance. Compute and compare the motor winding losses before and after adding the resistance. So now we're going to calculate the before and after adding the R resistance, additional resistance. So before that, they have mentioned there's a drop of 8%. So we calculate the new speed, which is the 1322 RPM, followed by we calculate the sleep. Then the torque is constant, so we assume it's equal to 1. From there, we obtain the resistance value, which is 0.44 ohms. So before adding, we're calculating the P winding, which is 2426.54 watts. So after adding the R additional resistance, the developed power is 2444, sorry, 24,442.3 watts. And using this formula, we calculate the current again, which is 40.17 amps, and the winding power is 4557.2 watts. So from here, we can see that when the resistance is added, the motor winding losses, the power of the winding is increased from 2626 1.5 watts to, to 4557.2 watts. Thank you.